In this video, we're going to be looking at the differences between linear and exponential functions. And you might be going, oh no, we're diving off into what a traditional math class will be. And yes, this is probably our most mathy lesson that we do all semester. But the purpose here is more that if I have a situation, what might I be able to represent it with? Like if I wanted to set up an equation or make some conclusions, or could I generalize some answers? Just because both linear and exponential models tend to be quite frequently used. And so we just want a sort of comfortable grasp with them. Now in this first video, we're purely going to focus on what is the key difference between the two, and can we recognize situations that might be best represented with a linear function versus an exponential function. So before we get too far in, just a little bit of vocab for us. So the first vocab word we're going to look at is just a function. So you'll hear this a bunch throughout this lesson, and a function basically has a value you input, and for each of those input values, there's one output value that comes out. Think of it like a machine. If I type in 1, 10 is the only value that can possibly come out when I type in 1, sort of thing. And then just keep in mind as we work with graphs, when we deal with ordered pairs, the input value comes first, the output value comes second. You might be more comfortable thinking of that as, x, y. But the reason we're sort of avoiding using that is that for the most part, we're going to try and use meaningful variables in our situations, meaning letters that make sense within the context that they're representing. All right, so on to the linear and exponential functions. So let's start with linear. This should be the function you're probably the most comfortable with. And, you probably have always heard it, it has a constant rate of change, that constant growth. Well, in this class, we're going to add a little bit to that because we talked about some changes in the last lesson, and we referred to absolute change versus relative change. And if you remember, absolute change is actually sort of a change that's the amount that got added to the original amount. So an absolute change is a type of constant rate of change. So the linear functions are situations that have an absolute constant growth or decline. So we like to think of it as the rate of change is being added. Sort of it's an additive relationship. Each month it goes up by this specific dollar amount. So key thing here is that we got a constant rate of change. And so we in this class will be thinking about that as an absolute rate versus exponential functions. They increase by a percent sort of each unit of time. So it's like a percent growth or a percent decline or a multiplicative sort of relationship. And so if we think back to our previous lesson on change, we're looking at a relative growth or decline. And again, just like with the absolute one, this relative one is constant. So it's that same percent growth each time, but we'll refer to it, sort of as a relative change. So we have our absolute, we have our relative. And you'll notice here that I did give you sort of a generalization for an equation for either of these. We're going to come back to that in a later video. For now, the focus is linear, have that absolute constant rate of change. It's being added every unit of time, versus exponential have that percent or relative constant growth, which is going to be multiplied every time. So we're going to look at two situations, and here's what we're basically going to do. We want to figure out, is the rate of change absolute or relative? And therefore, is the situation linear and exponential? We're not actually going to solve any problems here. We're not going to answer the questions. It's more just can I pick out and identify which is which situation? We're also going to add in, is it increasing or decreasing? Just sort of general characteristics. All right, the number of students at a college increased, key word right there, by 450 students each year for the past 4 years. If the student population is 6,754 4 years ago, what is the population 2 years in the future? So The key here is that it increases by a specific number of students each year. So we would think of this as an absolute rate of change. And that would be, and if we wanted to list it out, it would be 450 students per year. And it's increasing. So, and since it's an absolute rate of change that's increasing, our function would be best described with a linear function. In contrast, if we look at the next problem, and I'm going to change the color just to sort of keep it separate, we have the price of milk has been rising 3.7% per year. The price of a gallon of milk was $2.77 2 years ago. What is the price today? So the key here is, again, we have that relative, that percent growth. So we have a relative rate of change, and that relative rate of change was 3.7% per year. So remember from last lesson, relative changes are going to be percents. It's rising, which means we're increasing. And since we're using a relative rate of change, we would model this with an exponential function. And now it's your turn to try and recognize, is it linear or exponential? If you click on to the next slide, you'll get a chance to try these sort of 3 situations and see if you can correctly identify them as best modeled with exponential or linear functions.